Hi, I'm Shreya, and this is my lab two for physics, and it's about a charge tape. The lab is essentially about seeing how a charged tape can interact with other objects, charged and uncharged, and then measuring things like how many electrons were lost, and like what that ratio is between total number of atoms and number of electrons that were transferred. Um, so the setup of this lab is pretty simple. We had a piece of just normal plastic tape, and you would use another piece of tape, stick the tapes together, and then rip them apart really fast so that you have like a charged tape. And then we were looking at a couple different things, how this tape interacts with something like our finger, which is a neutral object but acts as a dipole when the tape comes closer. And then we also looked at how that tape interacts with another charged tape. And we found that um, when there is there's a slight change in position that happens due to a force that is caused by another charged tape that's acting on said tape. And when that happens, we decided to record that change in distance and use that for a bunch of calculations. So here are some of the important equations we've used throughout this lab. Um, I think intuitively, the force of gravity is something that's acting on the tape that we used in our previous setup. And then we also have the electric force formula and the electric field formula as well. So initial observations that we recorded through the setup of this lab was that when we charged the tape was attracted to our fingers. And that is because our bodies are neutrally charged and becomes a dipole when we move a charged tape closer. So there's a transfer of electrons that happens when you touch the tape, and because of that, it lost its charge. And we had to do the experiment multiple times so that we could make sure that we're touching the tape as less as possible. And then when we tried using another charged tape and brought it close to a piece of charged tape, we found that they repelled because they were charged in the same way and they had the same like sign charge. So they were both either positive or both either negative. Um, and to figure out if it was positive or negatively charged, we decided to rub a plastic pen in our hair, which negatively charged the pen. And when we brought a piece of charged tape close to the pen, it attracted, which means that the tape was positively charged. So I used the distance that I calculated, the displacement of the tape that moved up due to bringing another charged tape close to it. And we did some calculations. So first, I made some assumptions that because the momentum of tape was zero, I realized that the force of gravity counteracts the electric force caused by the other charged tape, so that there's a balance, and the net force on this system is zero. And then I made this free body diagram here. This is how the distance between the two charge tapes, where B is the one that's the system, and it has forces due to A. And then I basically set the force of gravity equal to the electric force. And then after that, I was able to calculate the charge of the tape using the electric force equation and setting it equal to the gravitational force, which is just mass times the gravitational constant. And I got this 1.39 times 10 to the negative 16 as uh, the square root of that was my charge right here, 1.179 times 10 to the negative 8. Then to calculate the number of electrons lost, I basically took the absolute value of this charge and then divided by that by the charge of an electron. And I got 7.36 times 10 to the 10th. So it's a lot of electrons lost. Next, to calculate that ratio, I essentially started by finding the number of total atoms in the tape. I found the tape's area and atoms per area. And then I eventually took the number of total atoms divided by the number of electrons lost. And I got 5.43 times 10 to the sixth. I also implemented this with code, and I made kind of a simulation. I essentially set the constants that I specified and measured in the beginning of my experiment, and then I used Python to calculate things like the force of gravity, the charge on tape B, number of electrons lost, and then finally the electric field from B to A, and then that ratio. And here are the results of simulation. As you can see, the force of gravity counteracts equally the force due to the other charge tape. And my percentage difference with my answers and simulations answers, which are shown here, was 0.27%. And for the ratio, it was 1.82%, so pretty close. Some assumptions I made in my program when coding it was that air resistance is negligible, and it only acts upon like the only forces acting on the tape B is gravity and electric force due to A, and the tapes are also reduced to point charges. So I didn't really consider like the mass distribution or the charge distribution for the tapes. I just kind of reduced them to point charges for this lab, and then I also assumed that both tapes had the same charge in my equations. So to kind of sum things up, with two concluding questions, if we consider that electrons have positive charges and protons have negative charges, if they're flipped, I believe that the same things would happen and the interactions would be the same because fundamentally, like oppositely charged objects would attract and the same charges would um, would not. So I think a lot of the interactions we saw in this lab would still remain the same. And then, why is it important to handle the charge tapes as little as possible with your fingers? And if they come in contact with your hands, what happens? Like I said before, your fingers act as a dipole. So there is an electron transfer that happens when you touch the tape and it loses its charge, which is important in this case because not touching it would allow it to be charged and would allow us to calculate that displacement for this experiment. Thank you.